Can you tell me what it was? Do you remember you were given some assignments? Can you hear me? Okay. Anyway, we had covered TCP header, various flags of them, infields of them, and options. Now, today we are going to talk about some peculiar scenarios. Okay. So we said that TCP, because it is a reliable protocol, what functionalities are provided by TCP? Because it is a reliable protocol, what do we do in TCP? Or rather, which mechanisms or which provisions of TCP make it reliable? Whichever way you want to answer that. So we are doing error control. Yes, when I say it is reliable, we are doing error control. Can we go a bit in detail and tell me what do we do in error control? Anyone can unmute yourself and answer as well. If you don't want to type the longer statements, you can unmute and tell me that how do we make it reliable? We ensure data integrity. How do we do that? Verify data at the sender and receiver. And how do we verify the data? I hope there are 110 students who are listening and thinking it is just that they are feeling cold, so they don't want to take their hands out and type acknowledgement. Yes, we have checksum, acknowledgement, and checksum tells us whether data is correct. Acknowledgement tells the transmitter whether data has been received. And if acknowledgement is not reached in time, then retransmissions will be done. Nice. So I can say at the transmitter before sending data, we calculate the checksum, we send it and start a retransmission timer. What do we do at the receiver? At the receiver, when we receive the segment, we verify the checksum. If it matches, then acknowledgement will be generated and data will be passed on to the upper layer. This acknowledgement which is generated, once it is received in time at the transmitter will stop the retransmission timer and it is free from the responsibility of sending that segment because that has been acknowledged. Now, if you think from the receiver's perspective, then receiver has two jobs to do whenever it is getting a correct segment. Which two jobs? When receiver receives the segment correctly, it has to send an acknowledgement and yes, all of you are right. It has to send, yes, it has to send an acknowledgement as well as Kevin said that it has to pass the data to the application layer. These two things have to be done. That send an acknowledgement, that is one thing, and write data to the upper layer, which is application layer in this case. Now, I have a doubt here. Should we first write data to the application layer and then send an acknowledgement? Or should we first send an acknowledgement and then should write data to the upper layer? These are the two possibilities in which we can do these events. We have to do this both. But do you think order matters? Or we can do this or this, any one of this. So how do we implement a receiver? Would you go for the first scenario or the second scenario? So Dev and Abhi say that first we should send acknowledgement, while Prince is saying that first we should pass on data. So are you just saying that with some preconceived notions, or you have some logic? Okay, because timer is running at the transmitter, so Abhi says that first we should send the acknowledgement so that timer will be off. Okay, in Prince, what is your logic of saying that first we should pass on data to the upper layer? Okay, we'll come back to this again after a while. If acknowledgement is lost, then data duplication. That we have written data to the upper layer and then we are sending the acknowledgement. If acknowledgement is lost, then in this case also data will be retransmitted. But here fortunately we have provision of sequence number. Right? So once you have given up to, let us say, 10,000 bytes to the sequence number, byte which is having sequence number 10,000. So once if I'm getting something lesser than 10,000, I know that that has already been given to the upper layer. So I'll be accepting bytes which are above 10,000 only, and once they are in order, I'll give to the upper layer. Prince, this is what you were saying or something else? Okay, so let us pose this question at the moment and look at the title. I said that crash recovery. So that might happen that your host may crash at time, or not the entire host, but transport entity, the transport layer program which is running, if that is crashed for a moment due to some reason, the process is stuck or it is crashed. So if your receiver transport layer was down for a while, now when it is up, when I say down for a while, what do I mean by that? It is crashed. That means it has no memory now. It doesn't know that what was the past data. It doesn't know how much sequence number it has received so far, what acknowledgement was sent, up to how much data was given to the application layer, and what is stored in the buffer. Everything will be destroyed. That is what we mean by crash. It is not having any parameters record with it once it is rebooting after the crash. Once it is coming again properly in action after the crash, unfortunately it has no memory. By chance, if parameters are restored, just the memory or the buffer in which the data was written, if that data is lost only. But if we have maintained the parameter, then based on the parameter we can request our transmitter to send the data accordingly. But in case if we don't even remember how far had we reached, what was received, what was acknowledged, what was passed on to the upper layer, at that point of time we don't have any option but to tell the transmitter that I was down, you do now whatever you want to do. Okay, so let us say we are adopting a policy that whenever a receiver is down, what does receiver does? Receiver tells the transmitter that I wasn't available for a while. If you can do something for the recovery, do it. Okay. Are you with me so far? Fine. Please be with me. It is pretty interesting and easy as well. Just I need to explain you the possibilities at the transmitter and receiver. So at the receiver, we could have two policies. Okay. At the receiver, as we have discussed, we could have two policies. We could have that first send acknowledgement and then write the data, or I could have first write the data and then send acknowledgement. So let us try both the policies and see which one is good. You know, that first we are sending the acknowledgement and then we are giving data to the upper layer. So here it is first acknowledgement and then write. In the second one, I'm saying that first write and then send the acknowledgement. Now, we are assuming that we were down. Your receiver can crash at any point of time. You know, when the data was received, it might crash. Acknowledgement was sent and then it crashed. It was written and then it was crashed. We cannot predict that when it will be crashing. It could be just at any point of time. So we are checking out all the possibilities that crash took place in this sequence or in this sequence. C is for crash, okay, or in this sequence. Can you tell me, when I write WCA, what is meaning of that? WCA, how do you interpret that? Data was written to the upper layer and it was crashed before sending the acknowledgement. True. So that means data was already passed on to the upper layer. We were yet to generate the acknowledgement before it was crashed. These are the possibilities at the receiver. A receiver can have only these two implementations, and these are all the possibilities at the receiver. Now let us think from the transmitter's perspective. When your receiver tells that it was down for a while, what can your transmitter do? Your transmitter can always retransmit data. That is what your transmitter can do. It can always retransmit. That is one policy which we can adapt. Or receiver can say that, okay, whenever it is saying that it is down, never retransmit. Whatever was sent, let it be. Don't retransmit. Or whatever you are having, retransmit everything. These are the two possibilities. Or it can say that retransmit if acknowledgement is available. If you already have an acknowledgement, then retransmit. Or it can say that retransmit if acknowledgement is not available. Some of this might not make sense to you, but we are listing out all the possibilities to see that if we can do good in something. Can you think of any other possibility at the receiver or transmitter? I think that's it. These are the possibilities which we can have, isn't it? When the receiver says that I was down, we can always retransmit, or we can decide never to retransmit. Whenever it says it was down, then skip this and let us go ahead with the fresh data. We can do it. Or we can retransmit if acknowledgement was available, or we can retransmit if acknowledgement is not available. Now let us see one by one case. That receiver has sent the acknowledgement, then it was crashed, and data was not written to the upper layer. At the sender, if we are adopting the policy of always retransmit, then retransmission will be attempted here. Whenever receiver says crash, it will retransmit. Remember that is what we are doing in the retransmit. So here that will help, and our data will be in order, because we will write data once to the upper layer. Retransmission data will be to the upper layer and will be good. In this scenario, acknowledgement was sent, data was written, and then we crashed. When we are coming out of the crash, we are declaring to everyone that, okay, I was down for a while. So whenever we say we are down, it will be retransmitting. So data was already written once to the upper layer. Retransmission also will be given to the upper layer, because transport layer has no memory what was sent. So whatever it is getting, it will be sending that. So data is duplicated here. It was crashed. So data wasn't written to the upper layer. Now if you are getting the retransmission, it will help and everything would be in order. Have you understood this three? A, C, W. This one? Okay. So acknowledgement was sent. That means we have adopted this policy at the moment, that first send the acknowledgement, then write the data. So transport layer has generated the acknowledgement, sent it. And before it could write data to the application layer, transport layer entity was crashed. Now whenever it is up again, it is letting know the other transport layer sender that I was down. You may take some remedial actions if you want. So your transmitter is retransmitting that. So this retransmission will be coming to the transport layer. Transport layer doesn't remember whether it is sent or not. So once it is getting this retransmission, it will write to the upper layer. So once data will be given to the upper layer, when we write OK, that means everything is in order. Data is exactly written once to the upper layer. If we pass on data 2 times to the upper layer, then we are writing duplicate. We are failing there. If data is not given to the application layer even once, then it is lost. it is a case of data loss. So now, who will tell me what should I write here in WCA? What should we write? What is meaning of this? We had written, then it was crashed, and acknowledgement was not sent. So once it was written, now again there is a retransmission. So we are writing 2 times. So data will be duplicated. That is true. Kenil is true. Now I want roll number 1 to 10 to tell me what should I write here. 1 to 10. Data was written, acknowledgement was sent, and then it was crashed. Again we are retransmitting, so it will be duplicated. Juzar, you are right. 11 to 20. Let us make it fast, please. Anyone from 11 to 20? It was crashed. We were yet to be written, and acknowledgement was not sent. The policy at the transmitter is always retransmit. Okay, 21 to 30. Anyone from 21 to 30? If you have not understood this, let me know. Okay, 1 to 30. Anyone? 1 to 30? No one from 1 to 30 knows what should be written in the last one. Seriously? Can you tell me what should I write here? Yeah, it would be okay. Now we are adopting the policy never retransmit. We are saying that whenever receiver tells that it was crashed, let us forget about it and move on. Don't retransmit. So acknowledgement was sent, crash happened, and we didn't write to the upper layer. Before that, there was a crash. And we are adapting policy not to retransmit. That means retransmission is not done. So this data will never be given to the upper layer. So I'll write lost here. Roll number 31 to 40. Anyone from 31 to 40? 41 to 50? Okay, because we had written once to the upper layer before sending before there was a crash, so data is once given. And if there is no retransmission, that is fine. We'll be happy. So that is true. 51 to 60. Sahil, it will be lost. You are right. Yes, Akar, Chinil, all of you are right. Because it was a crash. We didn't write it. There is no retransmission. So data is not given even once to the application layer. So data is lost. 61 to 70. Nirav says it should be okay. And that is true because it was written once and there is no retransmission. So it will be exactly once. So we are good. 71 to 80. Next one. Vimal and Urshit and Parth, all of you are right. Yes, that would be okay. Yes, Devansh, that will be okay. So again, I'll give chance to 21 to 40. 21 to 40. Would you like to answer this now? Anyone from 21 to 40? Okay. Uh, it will be lost. You are right. That is true, Rikin. It will be lost because there was a crash. We didn't write and there is no retransmission, so we don't have data. It will be lost. So any one of you, feel free to ask me if you have any doubt in this. Have you all understood this? See, now there are a few hypotheses. I don't know which one of that is true. If you understood that, then you should answer it. I mean, you means those who are not answering. Or you understood that, but you are too lazy to answer that. Or you understood that, but this is too trivial for you to answer it. Or you probably don't even know what I'm talking about. So anyway, this one, please pay attention here now. But if you understood this should be very clear to you. Now we are retransmitting if acknowledgement has already been received by the transmitter. That is what we mean by this, retransmit if acknowledgement is available. So here acknowledgement was generated, then it was crashed, and then data was to be written to the upper layer, which we haven't done so far. And will the transmission be taking place in this scenario? If these are the events and if this is the policy, will we attempt retransmission? Yes, we will attempt retransmission. Will that retransmission help the retransmission will be attempted, but will it be useful here? Yes, isn't it? Yes, of course it will be very much useful to us because we haven't written data to the upper layer. So once we get the data, we will be able to write that to the upper layer and everything will be in order. Now here, acknowledgement was sent, data was written, and then there was a crash. Because this acknowledgement is available, we will be retransmitting. So once we had written, this is a retransmission. So that will be an event of duplication. Right. So I think now all of you got the idea about this. Can you quickly fill this table and tell me once you are done? Will data be lost here? In this scenario where the cursor is, should I write lost? Kevin, hold on, please. Do not write everything here. So now 81 to 90. 81 to 90. What should I write in these two columns? Can you please tell me? This and this. In case of WAC, data was written, acknowledgement was generated, and then it was crashed. So that is the case of duplication. That is true. And the next one, there was a crash, data wasn't written. Because acknowledgement is not available at the transmitter, there will be no retransmission. And in this scenario, data will be lost. Yes, Shyam, that is true. Now in the last one, probably this made the most sense to us if you are using, just in or what do you say, instincts. Because if retransmit, if acknowledgement is not available, that is what we thought that would be making the most sense and it would be efficient. Let us see how it performs here. So acknowledgement was generated, then it was crashed. So here acknowledgement is available. Will the transmission be taking place? No. Yes, retransmission wouldn't take place, and as you said, it would be lost. Yes, all of you are right. Now anyone can tell me what should I write in this 5, and let us do it very quickly. Okay, next is okay. Okay. In WCA, duplicate. Yes, duplicate. Then WSC, and the last one, okay. So now after doing this exercise, what do we realize? That some of you said that first we should be writing data to the upper layer and then we should send an acknowledgement. You know, but if you're adopting that policy, then doesn't matter whatever we do at the transmitter, we are never safe, or rather we can never say that we are reliable. And please remember that duplications are as bad as lost data. Once the data is incorrect in any form, missing or the duplicate, that is not acceptable to us. Data has to be received exactly once. Then only it is data integrity is maintained and we are good with that. Or some of you said that first we should be sending the acknowledgement and then we should write data to the upper layer. In this scenario also, doesn't matter whatever policy we adopted the transmitter, we are failing. So whether you are doing anything at the receiver or you are doing anything at the transmitter, it is not in the control of the transport layer to recover if there was a crash and everything was lost, including the parameters. However, if you take help of the application layer, by chance, if you involve application layer, and if your application layer tells you that how much data was received, and if you have kind of replica from the application layer, you might be able to do something. But then it would be violating the layering hierarchy. So if layer K crashes on its own, doesn't matter whatever you try to do at the transmitter or receiver, you are never 100% safe. However, if we still have to go for the lesser evil kind of scenario, we will say that this policy is good, because here whenever acknowledgement is not available, we are retransmitting. There is 33% data loss. Here also 33% duplication. So if you think about this, then at the receiver, actually whatever you do doesn't matter much. This event or this sequence, both of them are more or less same. Am I making any sense to you? Okay, nice. So without intervention from the upper layer on its own might not be able to recover from the mess which was created after the crash. Okay, so now let us talk about something else. Let us talk about the performance issues in TCP. And there is a peculiar scenario that if the transmitter is very slow, transmitter as in I mean by transmitter application. Transmitter application is very slow, like you are writing just hi and then you are sending that. So if there is a chat application, then one segment will be sent. So what will happen? At the transport layer, TCP header will come into the picture. Even if we don't consider any options, then 20 bytes of the TCP headers will be there. Then 20 bytes of the IP header will be there. This is your IP header. This is your TCP header. This is without any option. And then I'm not even considering the data link layer. If you're using data link layer, then again at the data link layer, we have header and tailer. And all of this is just to send, hi. So it is still there are some bits in that, but even if there is just 1 byte, then this much overhead will be there. And that's not it. This is in the forward link. Because TCP is a reliable protocol, in the reverse link, acknowledgement will be generated. So again, in the acknowledgement, you will be having 20 bytes of TCP, 20 bytes of IP, and then data link layer, header and tailer. So actually, our network will be more busy sending the assisting data than the actual data. And this should be avoided because this deteriorates the performance. Do you agree with this? We shouldn't send tiny segments. Yes or no? So now, what is worse? Not just this. Like you send just one byte. If I want to continue with this, you send one byte and there was 40 bytes of overhead, then again acknowledgement. And after you sent one byte, again 2 bytes were available. Then you send those 2 bytes. After you sent this, then 1 byte was available. So again, you constructed a segment, you send that. Then again, you had probably 1 byte, then you had 3 bytes and so on. So if you are doing this once or twice, that is okay. But if continuously something like this happens, then we are not utilizing the resources wisely and fairly. So can you suggest me any solution to remove this? What should we do so that we don't generate the tiny segments? Because we don't want overhead of the headers which doesn't contribute actually in the data delivery. Can you think of any solution? Because your application layer sends you 1 byte, 2 byte, 1 byte, 3 bytes, 1 byte. Transport layer is sending that. No, you cannot send header only once, Keval, because in the header you have information, and without that, I mean, what do you like? How do you suggest that, Keval? Can you unmute yourself and tell me?
Yes, ma'am. I'm telling that before making connection to any sender between the sender and receiver, sender first send this information through the header, and once it is got the acknowledgement from the receiver, then it just transmit only messages.
Okay. So when you send the message, what do you mean by that? Don't we need to tell that message that to which port address this has to be delivered, or to which IP address it should be delivered?
We need to tell.
And I think I need to clarify here one thing. When I say connection, that is not a dedicated connection. Like it is not a pipeline, like you are sending something here, then it will be received just at the other end. It isn't like that. By connection at the transport layer, we just mean that 2 endpoints are defined and both of them have agreed from each other to receive and transmit data. That is what all we mean by the connection. Here there is no physical connection. There is no even virtual connection. The path is decided by the network layer, by routing, right? So when I said the transport layer, we have established a connection. What all we know is we have asked receiver, are you ready? Receiver said that yes, MSS was agreed upon. It has allocated some buffer to you. So unlike UDP and UDP, it might happen that you are sending data and there is no one actually there to receive the data. Or the receiver is too busy to entertain your data and they might be thrown away. While in TCP, that doesn't happen. We are taking permission from both the ends. We are defining 2 endpoints. So connection at the best at the transport layer is just having 2 endpoints. That's all we mean by connection. So it isn't so that once we are sending the header and then subsequently whatever data we send at any point of time, they will be sent. No, because all the segments are independent, and it might happen that your transmitter is talking to 5 other receivers, like one Google server, one your FTP local server, one your friend, you are chatting with friends, something like that. So when you are sending data, you need to tell to which computer you are sending the data, to which IP address this data is meant for. And even if you are sending to just one Google also, you might be having, let us say, 5 tabs. So you need to tell which application is sending this data and for which application it is meant for. So IP address and port address combination is inevitable. We will have to write TCP header and IP header with all the data. Doesn't matter how tiny or how giant the segment is. Do you agree with this? Okay. Yes, Keval, you do. What about others? Have you understood the question and the discussion? Others? It isn't so that the question was or the answer was raised by Keval, only he would hear that. So anyway, yes, we are going to channel. Channel said that batch transmit. Yes, channel. Can you elaborate that? What do you mean by that? Would you unmute yourself and tell me? Mm, okay, you have thought of some counter argument to your ones. Okay, so here what is proposed that whenever you are sending, whenever the first segment is there, doesn't matter how tiny it is, send it as it is. And then wait. For how much time should you be waiting? Wait for the acknowledgement to come, or wait until you have one maximum segment worth data. Whichever takes place earlier, then you are free to construct the next segment and you can send it. What are we saying? That whatever you have in the first one, if you have just 5 bytes, send 5 bytes, construct a segment, send it, and then wait. If application is giving you 2 bytes, 1 byte, 3 bytes, then keep accumulating that. You will not be constructing segments as and when your application is giving you. We will accumulate that. And we are waiting for acknowledgement to arrive. Before acknowledgement arrives, if we already have 1 MSS worth data, then fine, we don't need to wait, because you are never going to send more than one maximum segment size worth of data in one segment. Then we can send it. Or if acknowledgement has come and still you don't have 1 MSS worth data, fine, we have waited for sufficient time. How much time? 1 RTT, 1 round trip time. Your data was delivered to the receiver and acknowledgement was generated. So we wait for sufficient time. Whatever you have accumulated so far, 1 byte, 50 byte, 100 byte, 200 bytes, make a segment, send it. Again the same policy. Wait for either acknowledgement to arrive or wait for decent amount of data. So here we are waiting for time or decent amount of data. Option is given, whichever happens earlier, according to that we'll be constructing the segments and then we'll be sending that. This solution is known as Nagel's solution, in which is incorporated in all the operating systems. Nagel said that don't generate tiny segments as and when your application is giving that, but wait for decent amount of time or decent amount of data, so that we don't overburden the network. Are we on the same page? So now, this is the problem which is caused by slow transmitter. The transmitter is so slow that something like this happens. Now there is a possibility the transmitter is fast. Transmitter is having sufficient amount of data to send. Let us say transmitter is having 100 GB to send at a time, and receiver declared its window size to be 1000 bytes. So whenever receiver declares window size to be 1000 bytes, then a transmitter will be sending 1000 bytes because it is having 100 GB. So it has sent 1000 bytes. Now transmitter's application is so slow that it is consuming data very slowly. The buffer is full, with the buffer for this connection which was allocated to you, receiver's window size, it is full. Now receiver just read 5 bytes from that. Then what will receiver do? Receiver means receiver's application. Application has just consumed 5 bytes. Then receiver will declare that window size is 5. Then because transmitter is having too much amount of data, transmitter will be sending 5 bytes. Now receiver has consumed 3 more bytes. It will be saying 3 bytes. I'm making it dramatic by saying 2 or 3 bytes. Even if it is 100 bytes, it is not wise to use other 100 bytes to send 100 bytes. So even that is not good. So if receiver says that 50 bytes are available, then transmitter will be constructing a segment of 50 bytes. So here, if you look at this, the root cause of the problem is not the transmitter. It is sending tiny segments because receiver is indirectly compelling it to send it, because transmitter has data and it is desperate to send this data. So receiver is declaring small window sizes and then transmitter is constructing segments according to that. And why is receiver doing that? Because receiver's application is consuming data very slowly. So transport layer buffer is being released in slow bytes, and accordingly it has been declared. So here also we have a problem where we are wasting more bytes in the assisting data rather than the actual data. So what do you think could be the possible solution? Will Nagel's solution work here? No, right? So what do you think is a possible solution? Can you think of something? So here Clark's algorithm will come into the picture. What he said that don't declare tiny windows. Keep reporting 0 window size until half the buffer is available or 1 MSS data can be incorporated. So receiver shouldn't report any window size whenever it is having very small window size. If the buffer is of 100 bytes, then whenever 50 bytes are available, it can report that. Or if the buffer was of 1000 and the maximum segment size was, let us say 200. For an example, we have decided our maximum segment size to be 200. Then whenever you can accommodate one maximum segment size, then it can be declared. So we are waiting for half the buffer to be empty or one MSS to be accommodated. In that case only, your receiver should report the window size. Otherwise, it should keep reporting 0. And this particular problem, I forgot to tell you, is known as silly window syndrome. Because we are reporting very tiny windows and that causes our transmitter to send data inefficiently. So solution to silly window syndrome is suggested by Clark, who said keep declaring 0 window size until you have decent amount of space available. And how do we decide decent amount of space? Either 1 MSS or half the buffer. Are we on the same page? So can we use Clark's solution and Nagel's solution together? Can we use both the solutions together? Come on, I have high expectations from you and you're a smart bitch. So I don't understand. Of course, we can use both the solutions together, isn't it? They're complementary to each other. One is the solution of the slow transmitter, one is the solution of the slow receiver. And all the operating systems incorporate the solutions so that they are not being greedy and generating the tiny segments, because everyone, if they behave responsibly, then only network will be useful to everyone. Network is a shared resource. Communication channels are shared resources. We cannot think that, okay, whatever happens to other, let me generate the tiny segments. Doesn't matter, overhead is there, but my 1 byte is delivered, my 3 bytes are delivered. If you do that, everyone is going to do the same. And eventually, none of you will be able to send the data. So, in order to have the shared resource being used fairly and wisely, the solutions are incorporated in all the operating systems. Anyway, if you have any doubt, you can ask me. Any doubt so far? Girls, is there any girl who can ask me any question or tell me whether you understood these things? We have discussed three things primarily today, that how to recover from a crash at the transport layer by adopting various policies at the transmitter and receiver. What happens if there is a slow transmitter, and what happens if there is a slow receiver? That is what we have talked about so far. So, is there any doubt so far? Have you understood that? Can anyone confirm? I'm primarily looking for answers from girls. Okay, and I'm dejected. So now, keep alive timer. Let us talk about the third timer. Whenever connection is idle for too long duration, at that time, keep alive timer will come into the picture and save us from blocking the resources forever. I think we've experienced that if you're logging in somewhere, if you will, bank session or something, if you will try for the long duration after half an hour, 1 hour, and when you try to do it, it will say that session is expired. Even in FTP, you can go for FTP which uses TCP connection here. So if you don't do any activity for the longer duration, after a while, when you try to do it, it might tell you that please log in again. So if there is no activity being done for the sufficiently long duration, at that time, keep alive timer will come into the picture and it will be sending the probe segment to other party that are you there. If still there is no one is responding, then the connection will be terminated. Why do we terminate the connection? Because here when I say connection is there, then one port number is occupied, some memory is preserved for that, and unnecessarily if there was malicious one who has established connections, and if there is no activity for the longer duration, then after a while we'll be releasing the connection so that other healthy connections can be given the priority and the resources. So that is third timer for you. Can you tell me which were earlier two timers? Yes, one is persistent timer, and then which was the other timer? Timeout. There is another name for that. Yes, I understand what you are saying, and you are meaning the right thing. But what is name of that timer? Not timeout timer. Timeout takes, yes, retransmission timer. Retransmission timer. And whenever that times out, then retransmission will be taking place. So retransmission timer, then persistent timer, and keep alive timer. So as such, TCP is a bidirectional protocol. Both of them send data to each other. But still, if we have to categorize, like when will retransmission timer come into the picture? When it is acting as a transmitter or receiver? Where do we start it? At the transmitter side or receiver side? Yes, you're right. Yes. It is started at the transmitter side. What about persistent timer? At which side is it started? Transmitter side. That is true. And when do we start that? When zero window size is reported by the receiver. Yes, that is true. At that point of time, we start the persistent timer. What about keep alive timer? Where do we start it? Transmitter or receiver? At which end do we start this timer? At both the ends. That we start at both the ends. Yes, you are right. We started, so all of you are right actually, We started at the receiver, we started at the transmitter, we started at both the ends. And Out of these three timer, which one do you think will be of the largest duration, of the longest duration? We have learned three timers of TCP. Which one do you think is of the longest duration? Of course, keep alive timer, isn't it? Keep alive timer will be of the longest duration. Yes. So default duration is 2 hours, but it can be configured. In most of the time, it is like kept lesser than 2 hours. It might be 30 minutes or 1 hour or that. But if you don't do anything, then default it is of 2 hours. Like if you don't do any activity for 2 hours, then it will be closing the session. So if there is no doubt in this, we can end the meeting. And whatever we have covered so far, that will be in the syllabus. So I'm here for 1 minute. If you have any doubt, feel free to ask me. If there is any question, you can ask me. Otherwise, of course, you can leave the meeting. Okay, so I think that's it. Thank you.